Hello, researchers. Welcome back. As you can see, I finally got a haircut. It was time. And I am now ready to jump in into teaching this lesson. This lesson is about samples. It's an excerpt from chapter 5 of your textbook. So, for determining what your sample is going to be, the first step is identifying your unit of analysis. And basically, the unit of analysis is the level, for example, the individual, the family, the school district, the level from which the data will be gathered. For most of us, it's going to be an individual, it's the student. We're going to gather student data and we're going to use that to make a decision. If you're working at the district level, you might be gathering classroom level data. And you're looking at a bunch of classrooms and looking at the classroom as a unit, okay, in order to do your study. Now, in your textbook, it says you might have different units of analysis, one for the dependent variable, one for the independent variable. No, we are not going to have different units of analysis for the dependent or the independent variable because that complicates the analysis too much for our purposes. For our purposes, if you're collecting data about something about a student, then that you're going to have that same data is going to apply to the student at the student level for both your independent and your dependent variables. Okay, so next you're going to specify your population and your sample. The population is the group of individuals who have some characteristic. And this is a group of individuals that we're interested in that have some characteristic. And the sample is the subgroup of your target population that the researchers actually plan to study for the purpose of making generalizations about the target population. Okay, samples yield estimates. The difference between a sample estimate and a true population value is called sampling error. So to visually show this, your target population is the larger group. Your sample is who you're actually gathering data from, or you get a sample of data is what you're getting, and that's what you're using to answer your research question. So, for example, let's say the population were all teachers in high schools in one city. Let's say you wanted to know how satisfied teachers were in Atlanta, Georgia, for example. Maybe your sample, everybody's going to be all the biology teachers are going to be at some kind of professional development, and you're there with your survey. Please fill this out so I can learn about how teachers feel about teaching in Atlanta, right? Um, I wouldn't choose only biology teachers because I would probably want a more representative sample. So I would want some people from teaching all different, subjects. Some people teaching biology, people teaching math, English, history, so on. Okay. But my sample is going to be a smaller set. It's not going to be all the teachers in Atlanta or all the teachers in Augusta or wherever the entire city is. It's going to be a smaller set of teachers. Let's say I want to find out about something that relates to college students in community colleges. Okay, I'm not going to be giving my survey or interviewing all the college students in all the community colleges. I'm going to maybe choose students in one community college and then and interview those students to answer my research question. That's my sample. For how about adult educators in schools of education? Yes. So, am I going to go to every single school or college of education in the U.S.? No. Maybe I'm living in the Midwest, say South Dakota, where it's very cold right now. And maybe I'm going to choose educators that are in the 5 schools of education nearest to me, where I am. Okay. If I were in the Midwest, where it's very cold. Okay, so basically there are two sampling approaches. One is probability sampling, the other is non-probability sampling. Probability sampling is the selection of individuals from the population such that each individual has a chance of being selected. Probability sampling is important for quantitative research. It's not necessary for qualitative research, but it's important for quantitative research because quantitative research is based on the idea that you want a sample that is representative of a larger population. Okay? And probability sampling allows you to make that claim, usually, not always. Non-probability sampling is the selection of participants because they are available, because they're convenient, or they represent some characteristic that the investigator wants to study. This is used in quantitative research, but then you have to show how your sample is representative of the population. Okay? So that can be difficult to do, not impossible, but it can be difficult to do. Non-probability sampling is more common in qualitative research. You're not trying to generalize to an entire population with qualitative research. You're trying to interpret individual experiences or the experiences of a small group of people. Okay? Two probability sampling approaches: simple random or systematic. Simple random, in both cases you're selecting a sample from the population so that all the population have an equal chance of being selected. You're using random numbers for simple random sampling, or you're drawing names out of a hat. Something like that. Something that's, seems random. That's why it's called random. Systematic, you're choosing every nth individual or site in the population until a desired sample size is achieved. So let's say I have a list of all the students in the school and I'm going to be interviewing certain students. Maybe I choose every third student, okay, until I get to the number that I need. Let's say it's 30. So I'm going to choose the third student, the sixth student, the ninth student, the 12th student, the 15th student, and so on, okay? Um, you're trying to get a random selection of the students. Whatever order they're in should not relate at all um, to any of your variables. Okay, presumably one of your variables is not um, last name. How does last name relate to reading achievement? No. So the way they're sorted doesn't relate to your study, and that you can choose every nth individual, and it still can still be considered representative. Okay, so one way to draw a random sample is to, like I said, draw names out of a hat. Another way is to have that list and choose random numbers related to the order, right? And there are ways you can do this using computer programs. Random.org, if you go to that website, they have different ways that you can get lists of random numbers, or names can be sorted in a random way. Excel and SPSS both have functions for generating random numbers, and random sampling is important because you can claim that your sample's results generalize to a larger population. Okay. Now, when you're thinking about experiments, once you have your sample, individuals are assigned randomly to a group or different levels of the independent variable. For example, they're assigned to the treatment group or the control group. Okay, so you have selected your group of people that you want to study in your sample. Okay, regardless of whether it was probability sampling or non-probability sampling. You've got your people that you want to study, and then you divide them into groups, and you're basically going to assign them to a place in a random way. It shouldn't be systematic, right? You're not going to say, okay, all the girls are going to be in the treatment group, all the boys are going to be in the control group. No, it's not going to be systematic in that way because you want to claim that your groups are equivalent. Okay? If you're comparing two ways of teaching children about getting to a new place, and you would, let's say the choices were that you were either going to describe verbally how to get to a new place, or you were going to give the kids a map. Okay, and you're comparing these two ways, right, in your experiment. Since typically girls excel at verbal tasks relative to boys, and boys at spatial tasks relative to girls, you want to think about how kids are in the groups. Now, if they you randomly assign them, particularly if you have a relatively small sample size, you could end up with all the girls in the verbal group, right? And maybe they would do very well on average. Okay. What if all the girls were in the map group? You've randomly assigned them. You didn't mean for this to happen. If all the girls are What if all the girls are in the map group? Oh my goodness, I randomly assigned them, but the map group has all the girls or most of the kids in the map group are girls. Oh my goodness, what am I going to do? Okay, so researchers were faced with this kind of problem. And they came up with more sophisticated probability sampling approaches. So stratified sampling, that means putting the stratified is basically you're putting the population, using some population characteristic to place individuals on a strata, right? And then sampling from each stratum. Okay. For example, let's say it's gender. Let's say in your population you have 6,000 boys and 3,000 girls. Okay. For your sample, let's say you have enough money to give surveys to 300 kids. Okay. For your sample, because in the population there are twice as many boys as girls, for your sample, you want twice as many boys as girls in your sample as well. So, boys are two-thirds of the population. Two-thirds of 300 is 200. So you're going to survey 200 boys. You're going to survey 100 girls. Okay? So that your sample is similar to the population. Okay. For large scale studies, there's something called multi-stage cluster sampling. I just wanted you to see that term just to know that it's another kind of sampling. Um, yeah. Non-probability sampling approaches. Convenience sampling, selecting participants because they are willing and available to be studied. One of the things that um, yeah, if you all are going to be interviewing teachers in your schools, for example, maybe you choose the teachers that you're closest to that are most likely to say yes when you say, can I take some of your precious time and have you fill out this survey? Okay, purposive sampling. The researcher selects participants with a specific characteristic. For example, if you're studying homelessness, you're going to choose students in the district who are homeless to be part of your sample, right? Maybe you're looking at teacher retention, and you know that teachers are more likely to stay in the classroom when administrators are supportive. So maybe you're going to specifically survey administrators who are rated as very supportive by teachers in order to find out something else. Well, how are they supportive? What do they do? What do they say to their teachers? How often do they say it? That kind of thing. Now, snowball sampling is when the researcher asks participants to identify other participants to become members of the sample. You may not know all of the people who fall into a certain group. Okay. And snowball sampling allows you to find additional people. And this is used primarily in qualitative research. Okay. So let's say you find, um, you know of someone who is a leader and was a first generation college student, right? And now they're in a leadership role. Okay, well, are any of their friends, do they know anyone who's also a leader, who was also a first generation college student? They may have shared it, with someone and oh, yes, me too, and so they may be able to refer you to someone. Okay, and that might be easier than you going up to every leader that you see and saying, hey, were you a first generation college student? Okay, so that's what snowball sampling is. Okay, let's talk a little bit about notation, okay, because we're going to be starting to look at some numbers, and I want you all to be familiar with kind of some of the rules around notation. First of all, when we draw a sample, we're actually not sampling people. That's how we talk about it, and I talk about sampling students or participants, but we're sampling data about those people. So data for one variable, for example, a set of scores, test scores, is referred to by a letter. Usually it's a word when you're, writing it in a research report. But we can refer to it as a letter. So let's say test scores equals X. Okay. Then if we take that variable name X, which stands for test scores, the set of test scores shown in brackets there 75, 82, 91, 97. Okay? What's contained in that variable X, contained in the brackets or the box, the variable box X, 75, 82, 91, 97. That's our sample of test scores. Now, an individual test score is the variable name and a subscript number, right? So X sub 1 is 75. X sub 2 is 82. X sub 3 is 91. X sub 4, 97. Okay, you see how that works? The general form X sub I refers to any individual test score. Okay, it could be X sub 1, X sub 2, the I stands for any number. Okay, so knowing that, let's look at the summation sign. Okay, the summation sign is this capital sigma, right? Kind of looks like a weird looking E. That means sum, and as in add. And it goes from I, the index of summation. You're going to start at 1 and go to n. In the previous example, the stopping point, the number of the upper limit, the number of test scores we had in our sample was 4. So I would equal 1 and 2 and then 3 and then 4. X, okay, is the variable for test score, and then X sub I. So it could be X sub 1. And since this is a summation sign, it would be, it's essentially saying, please, could you go ahead and add test score 1 plus test score 2 plus test score 3 plus test score 4. Okay? We're going to sum X sub I from I equals 1 to n. Okay? Um, yes. And so, all right. We're going to don't worry about it. If that's a little vague for you right now, we're going to be talking about the summation sign more in future lessons. Okay. See you next time. Bye.